Hello guys, and welcome to this video to show you the correct method to balance out chemical equations. So let's get started. Before we actually start the balancing part, we need to know how to count atoms in a molecule. So I'll take just a little example here, which is the example of glucose, C6H12O6. Now this is your molecule. These are called subscripts, and they show you the number of atoms in this molecule. So if I ask you how many carbon atoms do I have here in this molecule, you'll tell me 6, because the subscript for carbon is 6. If I ask you how many hydrogens do I have, yes, 12, because the subscript is 12. And how many oxygens? It's 6. So this is the number of atoms in one molecule of glucose. Now there's nothing written here, so this is 1. Okay, what if I tell you that I have 6 molecules of glucose? Now this is called the coefficient. You can change it in a chemical equation to balance out the atoms. This is what we change. We never change the subscripts. Okay, I'll ask you here, how many carbon atoms do I have now? What you do is you multiply the subscript with the coefficient. So 6 times 6, you have 36 atoms of carbon in 6 molecules of glucose. For hydrogen, 12 multiplied by the coefficient, which is 6, and you will get 72 hydrogen atoms in 6 molecules of glucose. Now for oxygen, you have 6 multiplied by the coefficient, which is 6, you get 36 atoms of oxygen. Now, why did we do this here? Because we're going to use these in the chemical reactions in order to balance out the equation. So let's take an example. The next example is a very simple one. It's just an example to show you how or what are the steps to balance the chemical reaction. Let's take H2 hydrogen plus N2 nitrogen gas. It will give us ammonia NH3. So the first thing you notice here is that you have 2 reactants and you have 1 product. This is one of the simple reactions to balance out. Let's start. First thing I'm going to look at is the nitrogen. How many nitrogens do I have here? I have 2. And how many nitrogens do I have here? I have 1. Why is it 1? Because here there's nothing, so it's a 1. Okay? Now, in the reactants I have 2 nitrogens. In the products I have 1 nitrogen. Now, I cannot change the subscript. I cannot put 2 here to balance them. This is wrong. You can never change the subscripts. What you can change is the coefficients, which is the number before the compound or the molecule itself. Okay, so here I have 2 nitrogens, here I have 1. I should multiply by 2. Why? Let's check. So this is 1. 2 times 1 is 2. And here you have 2. So 2 times 1, it's 2. They are equal on both sides. So nitrogen is now balanced. So for nitrogen, 1 times 2 will give you 2 nitrogens, and in the products for nitrogen also 2 times 1 it will give you 2. So nitrogen is balanced. Remember that we do the balancing by applying the law of conservation of mass. All atoms should be equal in number on both sides, in reactants and the products. Okay, let's check now for hydrogen. Okay, how many hydrogens do I have here? 3. But since we have put the 2 here as a coefficient, now this 2 belongs to the whole molecule. So how many hydrogens do I have? I have 3 multiplied by the coefficient, multiplied by 2. So the number of hydrogens here is 6. Now I'll go to the reactant. I have hydrogen as a reactant. How many hydrogens do I have here? I have 2. Okay, and here I have 6 in the products. So what should I do? I should multiply 2 by a number to give me 6. In the product, if you look, it's 3 times 2. In the reactant, it would be 2 times 3 to give you 6. So here I put a 3. Now, if you check 3 times 2 for hydrogen, 6. 2 times 3, 6. Balanced. Nitrogen, 1 times 2 is equal to 2. 2 times 1 is equal to 2. So it is balanced on both sides. So guys, another example of balancing chemical reactions. Let's take this one. Al, aluminum, plus bromine, Br2. It will give us aluminum bromide, AlBr3. So this is the given. You need to balance the equation. So here, because the changing factor is this number and this number, I will start out by balancing bromine. I mean, you can start by balancing aluminum, but you will find out that you should start with bromine by trial and error. So let's start. For bromine, here I have 2 and here I have 3. How can I balance them? Whenever you have 2 and 3 on opposite sides in reactants and products, this 2, you should make it a 6 atom, and this 3, you should make it also a 6. How? 2, I'll put here a 3. So 3 times 2, 6. And here, I'll put a 2. So 2 times 3, 6. They are now balanced, the bromine. Okay, so for bromine, here is 3 times 2, which is 6. And also for bromine here, it's 2 times 3, which is also 6. Now I go to Al. Since you have changed the coefficient here, and this is 1, so how many Al do you have here? 2 times 1, or Al, 2 times 1, so this will give you 2. Now I'll go to the reactant. How many Al do I have here? There's nothing written, so it's 1 atom of Al. So here I have 2 atoms, and here I have 1 atom. I should multiply by 2. Should I put the 2 here? No, this is wrong. You cannot change the subscript. You can change only the coefficient. So now Al, This is 2 multiplied by 1. It will give you 2. Are they equal on both sides? Yes. 2 times 1 is 2. 2 times 1 is 2. Now for BR, 3 times 2, 6. 2 times 3, 6. So the equation is balanced.